This is our battery system here at Metagrid. I wanted to show everyone what I've done to protect the system and how I've got it configured. So I have 14 of the BYD modules purchased used. They came from a solar farm apparently, and I purchased them from an online wholesale outfit that disposes of surplus equipment. I've got it arranged in 2 towers, 7 modules in each tower. Each tower is connected parallel vertically and then serial to its neighbor tower to provide 48 volts at our outback inverter. I've also connected each cell in each module in parallel in order to keep the cells balanced and to help any weak cells get a boost from their upstairs or downstairs neighbors. So basically what I did is I just used some DC wire here and connected to a terminal. So on this side, all of these wires go to each individual cell. And then these wires, these color-coded wires, go to a bus that connects all the cells. So the one thing that I want to point out is if you put a multimeter probe on this, which is the main negative, and this, you'll get the voltage for the cell 1. If you put the probe for the multimeter negative here and positive here, you'll get the voltage for cell 2. Negative here, positive here, voltage for cell 3, etc. on down. So by connecting them this way and then to a bus that connects all of these cells, they each can share their energy with each other and keep each other balanced and protect each other from overcharge and over discharge. And I found it to be a very effective system. All the cells within each tower were staying very nicely balanced within just a few millivolts of each other. What I did find, though, is each tower was getting out of balance with its neighbor. So the voltage on this tower ended up rising very slowly as we went through a few charge and discharge cycles. For instance, I believe the voltage got up to, say, 26.8 when the voltage on this tower was 26.4. And so I needed some sort of system to keep the 2 towers in balance and to also, you know, just balance each cell channel on each parallel bus, on each cell parallel bus, which is these wires here that run between each cell. So what I found was a 5 amp active balancer on eBay from the eBay store IC Go Go Go, shipped from China or Hong Kong, not sure which. And I hooked that. I hooked the cell parallel bus to a another terminal block, which you can see here. And then from there, I ran a wire from each cell channel to the active balancer, which is right there. And so what we have is just a breakout board with pins on it. And I just use these regular RC connectors. And then that connects to the main control unit, which is up here. And that has a Bluetooth connection. I've just got an old Android phone in here that I use to monitor and control the unit. And what I've found is that does a wonderful job of balancing the 2 towers. I mean, it's a 16S, it's configured as a 16S active balancer, so it'll transfer up to 5 amps from any cell group on this tower to any cell group on this tower, or any cell group on this tower to any other cell group that gets slightly out of balance. And so I've been running this way for a month and a half, 2 months, and it keeps it, say, under 5 millivolt delta difference between each cell group. And I've decided not to run a BMS on this system. I'm just relying on my low voltage disconnect on my inverter to disconnect from the battery should the overall voltage drop too low. And I'm relying on my Midnight Classic 250 charge controller to avoid overcharging the entire system. And since the active balancer keeps the cells in balance, I haven't seen any need to protect the battery from any one cell or cell group getting out of whack. I mean, they just haven't gotten out of whack. And even before I got the active balancer, they weren't getting out of whack because of the cell paralleling that I've done. So I feel like a BMS at this point would just add complexity and mode of failure that would endanger the battery, and I feel like it's running much healthier and safer without a BMS. So that's the system we've got now, and we're gonna start hooking up all of our solar panels. We've got about 1,000 watts of panels coming in now, and it's doing a wonderful job, but we've got about 3,000 more watts of panels to hook up here and just see what we get throughout the summer. So that's it for now. Signing off.